Welcome guys, welcome to channel. Now today we are going to discuss about the BGP protocol part 2. So before this video we have discussed about the BGP protocol part 1. In that we have discussed the basic concept. Now today we are going to discuss about some advanced concept regarding the BGP. So let's start with the very first concept, that is what the how BGP works. So as we know guys, the BGP is a dynamic routing protocol. So it is duty of routing any routing protocol that it must maintain the routing table and take a decision on the basis of their own. Okay. So here, if you consider, let's say internet. So we know that the internet is what a combination of more than one network together. In that we have many routers are connected, and if this is the situation, that if that router is come first time on the internet, or let's say after being turned off, so what it will do? It will establish the connection with the other BGP routers with which it directly communicates. Okay, so if there is a directly connected network there, a directly connected router is there. So very first is what very first is BGP do. BGP establish the connection in between them. Then what first thing is does, it download the entire routing table of each neighbor routers. Okay, because in first time he has came to that particular network, you don't know anything about that routes. So what he does, he download the entire routing table for each routing, that is neighbor routers. After that, it only exchange much shorter update messages with other routers. Okay, by time it is going to be sent the much shorter update message to others. Then each BGP router contains the routing information base, that is RIB. It is, we can say, it is what the kind of data structure that contain the routing information maintained by the router itself. So here in this RIB, there are three types of informations are available. Very first ADG, that adjacent RIB in, it it is what unedited, unfiltered routing information sent by the neighbor routers. So it means what, this information is learned by the neighbor routers, and this information going to be used for the decision purpose. So the information going to be updated or maintained in this particular first field of that particular RIB. Second will be LOC, that is local RIB. This is the actual routing information that router uses, developed from this particular adjacent RIB in, and this is what the resultant info. The resultant info is available in this particular local RIB. And third is what, adjacent RIB out, the information that router chooses to send to the neighbor routers, and that is what selected by the local BGP. So whatever the information is available with that particular router, which is learned from that local BGP, it is going to be sent to the neighbor routers. It means what we can say. So BGP algorithm is run after the BGP router received an updated message from the neighbor router. It means what? If we compare this, the very first thing is it BGP will do does, it is what the update. What is update? Every routers have their own tables. If it received for other information from the other neighbors, it means what? It update that information if and only if that information is new and latest to that particular. If already is available information, that it is not need to be updated. So this is what the first update. Second, the second is what the decision. If it is a new information, then decision process is run. They determine the BGP routers of all those presently recorded, the adjacent RIB in database has the base route path for the IP address in the update message. Okay, so decision is going to be taken on the basis for what the best route, for what the best route. So whatever the updated information available in that particular local router, on the basis of that decision is be taken. And decision for what purpose? Decision for what the best routing protocol, best route purpose. Then this best route, after calculation of best route, what we have to do, we have to propagate that, we have to advertise that information to the other neighbors. Okay, so this is the key points of every router, every dynamic routing protocol, that it received update the information from the others. If it is already there, reject it. If not there, accept it. Then decision is taken. After that decision, the propagation is to be taken. So in this simple manner, the BGP works, and this is going to be done all by the speaker node we have discussed earlier. Then there are another concept, that is a type of autonomous system, guys. We know the definition of autonomous system, that autonomous system is what combination of more than one devices, or maybe the router protocols, etc., which govern by their own system mechanisms, the system administrator or the policy oriented document. Okay, there are three types of autonomous system. And this autonomous system only because we have a internet, and internet is what very large, and that internet is, if the internet is very large, that internet need to be divided into some autonomous systems, some regions. Okay, so to handling, debugging, maintaining is going to be easy. Okay, on that perspective, what we have three types of autonomous system. Very first is the stub autonomous system. Here only one connection is available to the other autonomous system. In stub autonomous system, there is only one connection available to the other autonomous system. It is the host in any autonomous system can send and receive data traffic to other autonomous system via only the one connection is available. Okay, the best example of this stub is what the small local ISP in that particular region. Okay, the size of this particular autonomous system will be less than the others. And then second will be multi-homed autonomous system. Multi-homed autonomous system, it has more than one connection to the other autonomous system. Okay, there can be multiple connections to reach to the other autonomous system, and it can send traffic to more than one autonomous system. It is also possible because multiple homes are available, more than one autonomous systems are involved. Okay, and the best example to the of this multi-home is what large corporation or maybe the regional or national autonomous system. So this is what the big example. And third is what the transient autonomous system. In this transient autonomous system, this is what the brief what kind of things. This autonomous system is multi-home. Okay, autonomous system that also allow the transient traffic to outside the autonomous system. So outside the autonomous system is possible only because of transient system. And good example of transient autonomous system is what the national and international ISPs. That is what the internet backbone. If you see the diagram, guys, in the first for the stub networks, so AS, that's AS autonomous system 2 and autonomous system 5. These are the examples of what the stub network. And autonomous system 2, okay, it is what the multi-home stub network because involved more than one what we can say the autonomous system. And third is what autonomous system 3 and autonomous system 4. This 3 and this is 4 is belongs to the transient network, guys. Okay, so this is the concept about the autonomous system, only to divide the internet into some different regions. Then there are two concepts. There are another concept is what the BGP station. What the BGP station and what the purpose is. The exchange of routing information between the two routers using the BGP. Okay, it is done, and to it takes place in the session. It takes place in the session via, or we can say via sessions. What the session is? The session is a connection that established between the two BGP routers only for sake of exchanging routing information. If the let's say R1 and R2 is there, R2 is there. So to in order to exchange the information, what we require a session, we require a path via which we can send the information. For that purpose, sessions are required. BGP session is a link between two BGP protocols endpoint. Let's say this is what the output and this is what the output of this router. So to exchange this information, we require endpoints. So that is endpoint is available. And each complete BGP session connect two BGP protocol endpoints also we can see. And to create a reliable environment, BGP uses the services of TCP, and that is TCP is what connection oriented. So we can say TCP is what the connection oriented mechanism through which the BGP is establishes the connection between two endpoints via some protocols. So there are two types of session, guys. Very first is what the eBGP. It is used to exchange the information between two speaker nodes in different areas. Let's say this is what the one autonomous system and second is this. So autonomous system 1 and autonomous system 2. So eBGP is what external BGP you can say or exterior BGP you can say. Okay. In order to send this what particular, let's say take this A1 is the router of this particular autonomous system 1 and B1 is what another router of the autonomous system 2. To exchange information between these two different autonomous system, what we have the eBGP. And what we have second is what the iBGP is used to exchange the information in two routers within the autonomous system. Let's say if I have A2 over here and A4 over here. So in between this, the exchange of information is done only with the interior BGP, we can say. Okay. So here the notation is available. This is what the eBGP and this is what the XBGP. So we iBGP, we can say iBGP is within autonomous system, eBGP is what the outside the autonomous system. Okay. After that, discussing the session, what we have a format, guys. Format of this BGP protocol. So there are only three fields available. Very first is what the marker, second length, and then type. Marker is what it is used for the authentication purpose. As we know that the BGP protocol support for the security mechanism. So all the related stuff with the security is going to be stored over here. And then it is the length. It is total message including the header, the length of that particular header format, and then data. That is what the length. And the type is there are four types of messages available or packets are available. That is open, update, keep alive message, and notification message. This is what the backbone of this particular what we can say the BGP protocol. That messages are very important in this BGP protocol. So let's take one by one over here. Then the next term is what the BGP message. What do you mean by message? The size of the BGP message format is 32-bit long. They encode with different types of messages, and it is used for establishing the connection, maintaining and updating the neighbor relationship, notify and formatting the errors about the peer neighbors. Okay, so let's say there are multiple routers are available. So all the information are going to be, let's say, very first the connection is going to be established, the connection is going to be maintained, then the routing information is going to be updated, then relationship between this one we can maintain, and if any error occur, let's say this node corrupted, this is going to be sent to the other routers. Okay, for this purpose messages are going to be used. Okay, there are four types of messages. Let's take one by one the messages. Okay, very first message what we have, guys, open message. Open message, let's say open message is used to open an initial connection with the neighboring routers. Okay, if I have a router over here, router over here, so very first connection is to be established via open message. And what is the detailed theory about this? Open message is sent after the TCP connection has been established with the peer routers. Okay, so the connection has been established via TCP protocol, then open message is going to be sent. Once the open message has been sent and been accepted by the neighbor router, a keep alive message is sent. So here, once it received, let's see, once is received, what received is this hello. So it sent the keep alive message, send to acknowledge the open message. Okay, it sent the keep alive message that I am alive, I am alive. Okay, after the router that send the open message received a keep alive message, it returned to the BGP connects in is in the established state, and then update and keep alive and notification messages are sent. Okay, so when this acknowledgement received by the sender one or first one, then it is established the state in reach to the established state, and then it is ready for the update and keep alive and the notification message also. Okay, so moreover we can say the connection established and they are checked handshaking, we can say that they both are live and both can communicate with each other. Okay, there is a some simple format, guys. So this common header is compulsory for all the messages. We have discussed three fields are available, the marker kind of things, length is there, and the type of messages. So here the version, BGP opens, let's say, TCP connection to send the open messages. Then version is 4. Then my autonomous system, here the my autonomous system. This is the number of autonomous system. We have configured the BGP protocol with the packet tracer, and there we have set the autonomous system numbers. Then hold time until what it indicate hold time until receive the keep alive message, otherwise dead. So it is going to be hold over here. Then BGP identifier use IP addresses. So this IP address purpose, the BGP identifier is going to be used. Then optional parameter is also optional, but if it is not zero, the length of the parameter and the parameter's value. So this information can be stored. Okay, so the purpose of open is what we have discussed this in this slide particular. Okay, then go to the next slide, and this is what the next message, that is update message. Now meaning of this update message, to exchange the routing information between neighbor routers, let's say R1 and let's say R2. Once the open message is done and the setup is done, now here the exchanging can be takes place only with the help of the update message. Okay, because updating is very important to take a decision. We have discussed it earlier stage. Okay, because everybody don't have the every information at the initial stages, so they need to acquire the information from the other, so that the best route can be possible, or best other information can be possible. The update message that gets sent to all the BGP routers, including the peer node, containing one of the most important information in the BGP message. Okay, so in order to exchange the information, we require the update message, so that whatever the routers are connected in that particular network, everybody is getting that messages that there is something important announced, or important information is available with me, so it is my duty to share with others. Okay, then there is a common format is available, right? Header format, common header format is already compulsory. Then there are some fields are available, like uh, withdraw routers. It comprises of a list of all the route that must be deleted from the previous list. Then path, it is a new preferred route for the IP addresses. This path consists of the two pieces of information, that is IP addresses and the address of the next hop, we can say next router. In this path, that is used to route the message to the destination for the that particular address. So the path is what? So path is going to be keep the information of what the IP address of my system, and what is the next path, next hope to me, so that I can reach to the destination. So this is what very important, guys. Then unfeasible, I define the length of the next field. Okay, unfeasible. Then NLRI, this is what very important field over here. It defines the network that actually advertised by this message, and it has the length and the IP address prefix, and it also support for the what we can say the classless routing information. And this NLRI stand for network layer reachability information. This is very important, guys. Okay, so we have discussed over here the update message of this particular BGP protocol. Let's take the third message, and third message is what, or third packet is what, keep alive message. And this keep alive message, this the keep alive message is sent between the BGP neighbors to maintain the connectivity. To maintain the connectivity, in this packet, only three type of fields are going to be used. Okay, or moreover, in this keep alive message is going to be used for what? Each BGP router send 19-byte keep alive message to each neighboring router to let them know that it is still operational about every 30 seconds. Okay, so after every 30 seconds, it is going to be sent to other neighbors that I am still alive. One can communicate with me, one can other can send data to me. So advertising my existence in that particular network, it is keep alive message. Okay, so that each time the connection is going to be maintained. Now this type of information, which type of information? Three types of. The very first field is what? AAFI, that is address family identifier. So to keep the addresses of all the family identifier, it is going to be available over here. Then RES, that is reserved, it is set to 0. It is set to 0, then it's not going to be used. Then SAFI, that is subsequent address family identifier. So this also information available. Only to whom I need to send that particular message, that all the information is going to be available over here, so that I can say my existence is available in that particular. For that purpose, the keep alive message is going to be used. Then there is a fourth packet, and fourth last packet is available, that is notification message. What happened if life would good if everything is good, everything is good, but something goes wrong, that wrong information need to be sent, that the error is information to be sent. So it is used to indicate the errors such as incorrect or unreliable message received, and are followed by the immediate close of the connection with the neighboring routers. So moreover, we can say if there is any error occurs, there is any unreadable and incorrect messages are received, so that is going to be informed to particular sender. For that purpose, the notification message has been introduced. So over here, what we have, error code, because we have to inform the errors to the sender, that must comprise of what is the reason that for that particular that error. So here error code is available. So error code, this is 1 byte field define the category of the error, which type of error has occurred. Then second is what, the error subcode is available. Error subcode is available. In this 1 byte of field further define the type of error in each category. Okay, if there is, let's say, if my node is unreachable. So because of what the my node is unreachable, whether the host is not available, IP address not set, etc., etc., that kind of information going to be available. Then third is what, the error data, and this field can be used to give the more diagnostic information about the error. So let's take this error code and this subcode, guys. This is very important. Okay, so here there is a chart, and in this chart what we have, there are codes are available, 5 to 6 code are available. Let's take the very first message header error. In this code, what we have, subcodes are also available. There are 3 subcodes, like a synchronization problem, bad message length, and the bad message type. So by these reasons, the message header error can be occur, and this is going to be intimated to the others. Then open message error, it comprises of 6 subcodes, like unsupported version number, bad peer autonomous system, bad BGP identifier, unsupported optional parameters, authentication failure, and unacceptable holder time. Because of this reason, the open message error can be sent to that particular other peer routers. Then update message error. Okay, there are 11 subcodes are available, like what we can say, there is a malformed attribute list, unrecognized well-known attribute list, etc., etc. So this all the 11 codes are available. Because of this, we can say the update message error can be occur, and this is going to be informed to the other fields. Okay, then hold timer expire, there is no any subfield, directly hold timer, that there is a fixed timer is available. After that, it's going to be sent to every that is if I'm sending the keep alive message to after every 30 seconds, I need to send that keep alive message. I'm alive. I'm alive. Okay. Then finite state machine error. This defines the problem procedure error. There is no subfield available, no subcode is available. So it is indicating that the procedure error is available. Okay. And then there is last is what the Cs. There is no subcode defined is available for the Cs. So these are the different codes and subcodes are available, guys, about the BGP error or error message. That is fourth message. Okay. So, and this last slide, what we have the summary of BGP protocol, guys. So whatever we have discussed in the part 1, part 2. So every summary is available over here. So here need not to discuss. There all the points are available, whatever we have discussed in earlier uh, video lectures. So with BGP, we have part 1, part 2, and then configuration practical video lectures also available. So completely 3 video lectures you need to understand and see all the video lectures. Hope that, guys, BGP is going to be a backbone, not going to be, it is the backbone of internet. On the internet BGP is working, and we know that the BGP, all the stuffs. Thank you so much.